All right, good morning, everyone. Today is Thursday, September the 2nd. This is day 3 of 3 of 1.05 lesson. All right, so we had bell work on the board for quite a bit of time. Class, what is the answer for how many possible number of positive roots? So 3 or 1. Make sure you have the word or in there. 3 or 1, yeah. And how many possible negative solutions should we have? Just one. I would agree with you. Yeah. So just to kind of show that, right? So, this is probably the hardest part is, plugging in the negative x and simplifying. But yeah, we all should have counted. So nice job, everyone. Little review. All right. So today we're going to solve some polynomials. So we're going to calculate all roots of a polynomial. All right, make sure you have your paper, pencil, calculator. We're going to use all of, we're going to use some, we're going to use all of these today. Everything we learned this past week and last week. All right. All right, so this is kind of review here. So given the zeros roots are -2, 2, and 3, I want all of you to, find the fundamental theorem result, fundamental theorem of algebra. I then want you to find the Descartes rule of sign result, and then find the rational root theorem result, which is P's and Q's. So as a little refresher for this first one, all you're doing is taking the solutions and putting them in factored form and then multiplying them all together, right? So let me give you, I think about a minute might be okay, right? Maybe a minute. So before I start the timer, what are the factors? So writing it out, what should you write on your paper, the factored form? Let's make sure everyone's on the same page. X plus 2, x minus 2, and then x minus 3. Very good. I would agree with you. Yep. Yep. So we should all be on this page. We went from the solution form to the factored form. And all I got to do is just multiply them all together. So I'll give you, I think a minute should be enough. Ready to go. All right. Before writing the answer, answer this. How many terms does our final answer have? Oh, looks like everyone's saying 4. I would agree with you. Yeah, our answer should have 4 terms. All right. So what is the final answer? X cubed minus 3x squared minus 4x plus 12. Got someone else that agrees with that. We got another person. Yeah, I think that looks pretty good. How can we all be wrong, right? How can we all be wrong? So you're probably all right. All right, so let's see. Yep. X cubed minus 3x squared minus 4x plus 12. What did all of you get for x plus 2 times x minus 2? X squared minus 4. And what is that special binomial called? What is that special binomial called? Perfect square. Yeah, it's a difference of two squares, right? Yeah, and hopefully you recognize that. Hopefully you recognize going from x squared to x squared minus 4 to x plus 2x minus 2. Going that way, super easy, right? Difference of two squares. But hopefully you made that connection and you didn't necessarily have to FOIL it, right? We could have gone from this form to this form in one step if you knew how a difference of two squares factors, right? Now, if you did FOIL it, that's totally fine. You FOILed it, you combine like terms, you got to here anyway, right? It doesn't really matter, whatever makes the most sense to you. All right. So in order to answer the Descartes rule of sign, we have to have this answer, right? We need to know this. It has to be correct to answer this question. So the easy question is, how many possible positive roots will we find? Yes, a couple of 2 or 0s. All right. Yeah, right. Yeah, 2 or 0. I think that sounds right. 2 or 0. All right. And then for the, I don't know, we'll call it the harder one, right? It's only hard because you have to plug in negative x into all the x's and simplify first, right? So let me give you all 30 seconds to do that if you haven't already. And then I'll ask for that answer. 30 seconds. All right, everyone. How many negative possible roots will we find? 1. I agree. Yeah. So we all should have had. That, right? And then we do the visual check, right? We just do a line for no change and a little hump for a change. So it's easy to see when you draw it out like that, and we can see it's just 1. So nice job. All right. Now the PQ list. All right. Do any of you need more time to generate your PQ list? Just curious. We need more time. No. Okay, so we can just go right to it then. Let me answer this for me. How many numbers are in your PQ list? Your final answer. How many numbers do you have? Technically 12, right? Plus or minus, right? You have 6 of them written out, but plus or minus, technically 12. Okay. Anyone else agree? Total of 12, right? 6 written out, but plus or minus. Yeah. Okay. What's your p-value? What's your p-value is 12, and what's your q value? 1. Yep. Can you all hear my cat? All right, and then we just do the factors, right? And so just go ahead and write out what are the 6 numbers that we found. You don't have to put plus or minus. I understand. 1, 2, 3, 4, 6, and 12. Yeah, I agree. So, all right. So we just quickly review. We did the fundamental theorem of algebra result. We got this. We Descartes rule of sign. We got 2 or 0 or 1, pretending positive or negative, right? And then we did the PQ list. All right, how are we all feeling about generating all that stuff on this page? How are we feeling about that now? Probably a lot easier than we did when we first started learning it, right? Yeah, nice. Pretty simple, right? Pretty simple. All right, so let's try it again for this one. So this time, I'm giving you the actual result. I'm giving you the function, which is x to the fourth plus 2x squared minus 3. I want you to determine the result of this Descartes rule, and then also generate your PQ list. So I think this one is pretty fast. I'm going to give you all, I don't know, I think 2 minutes probably is plenty for this problem. And it will go fast. 2 minutes. Yeah, I'll do a show and tell of my animals sometime in the future. Maybe today if we have time. All right. What did everyone get for the Descartes rule result? One and one. Yeah, I agree. 1 and 1. Yep, should have got 1. And when you plug in the negative x, well, this one is pretty easy, right? Because whenever you plug in negative x to an even power makes it positive. Negative x to an even power makes it positive. So when you plugged it in, it didn't change, right? This is f of negative x is the same thing as just f of x, right? So that's why it makes sense that we just have the same answer, 1 and 1. Okay, all right. All right, so that tells us that we're going to have, we're definitely going to have one real solution that is positive and one that is negative. All right, now looking at this original function, how many solutions should we find? How many total solutions should we find? We should find 4. Now, we know for a fact one of them is positive, one of them is negative. What does that tell you about the other 2 that we should find? Yeah, the other 2 are imaginary. Yeah, see how it all kind of fits together? This really paints a picture of what we should find. It's kind of neat. All right, now what's your PQ list? What are those numbers? Plus or minus 1 and 3? Anyone else agree? Same? Okay. All right, I think I agree with you. Yeah, right. So there's that's super easy, right? Oops, that is a mistake. I not mean to type that 2 in there. That is a whoops. That is a whoops on my part. Yep. Yep. Ignore that 2. Pretend we never saw it. That's a typo. 1 and 3. All right. All right. How are we feeling about this page? This little review. All right. This past week, right, of knowledge. It seems easy now. Good. All right, so this says on this very bottom that, well, once we do all this, we actually want to find all of the roots of this, right? So based on this, we know that one of them will be a real positive answer, one of them will be a real negative answer. And we already talked about that the other two should be imaginary. So we need to find all four solutions. All right. So given this problem, how can we start this? How can we find at least the first two? Any ideas? Synthetic division. So how do we select our numbers for synthetic division? The PQ list, very good. Yeah. So going back here, we only have what, like four? We got plus or minus one and plus or minus three. So we would just guess and check to see, because we know that two of them should work, right? Two of these should work, whether it's plus or minus one or plus or minus three, or maybe a plus one and a plus three, or a minus one. Actually, we got to have one of each, right? Yeah, so plus or minus one, it could be plus or minus three, it could be a plus one and a minus three, it could be a minus one and a plus three. Right, those are the only combinations that will work. Is there another way that we could kind of speed this up instead of using that PQ list, maybe? Ooh, Isaiah says graph it. Yes, let's all graph it. Go to Desmos and let's graph this to see what happens. All right, let's graph it real quick. And, somebody, once you graph it, what does the graph tell you? Ooh, so B says that the graph tells us that negative one and one look like they could be solutions. So remember, don't always trust a graph. We have to verify mathematically to make sure that it's, what we're seeing is true. Okay. Now, if you in Desmos, if you click on that point, it'll tell you the coordinate, and that will be accurate. And if it says like negative 1 comma 0 and 1 comma 0, they work, right? So we have to do synthetic substitution to verify. And I went ahead and I graphed it. So there's the graph from Desmos, right? And we can see that it crosses at negative 1 and positive 1. So let's verify that they actually work by doing synthetic substitution. Now I think I did negative 1 first. All right. What are these numbers that I have to put right here? Go ahead and write them in chat if you could, please. What are those numbers? Well, they are coefficients, right? But what are those coefficients? Ooh, looks like Isabel says 1, 0, 2, 0, and negative 3. Ooh, placeholders, everyone. Placeholders. Yeah, we're missing the x cubed. We're missing the x term. So we have to have placeholders. Very good. People who caught that. All right, so 1, 0, 2, 0, negative 3. All right, so everyone quickly do synthetic substitution with negative 1 and verify and tell me, does it work? Does it work? All right, so we have some yeses, yes, question mark. Now, Isaiah or anybody, how do we know it works? Like, what tells us, yes, this works? So B says, wait, I thought we're supposed to start with 1 and not do negative. So yeah, you're thinking of the upper bound and lower bound theorem. We're not doing that today. Yeah, this we're just verifying that these zeros work. All right, so to my question before is, how do we know it works? Well, Looks like Enzo says we get 0 as the remainder, and he is correct. Yes, so if you get 0 as the remainder, we know that it works. So I'm not going to bore you with the details, but yeah, we get 0 as the remainder. So that means -1 works. All right. Now let's verify that the other root works. Let's verify that 1 works. So what we're going to do is we're going to do the same thing, and you're going to use the remainder, right? We're going to use what's left. Show. Okay. Before we set that up, what is this polynomial? Now that we reduced it by a factor of x plus 1, what is this polynomial? X cubed minus x squared plus 3x minus 3. Looks good to me. So right now that is what we have for the factored form, right? That's the factored form. So x plus 1 times, remember, we opposite, right? These are roots and zeros, and this is the factored form. We just take the opposite, right? So this is x plus 1, and then this is, well, what's left of the polynomial after we reduce it by that factor, right? All right, now let's use this to do synthetic division again, but now with 1 as the root. All right, so everyone quickly do that and let me know, does it work? And how do we know it works? Remainder 0. Yeah, the remainder 0. So again, I won't bore you with the details because we all should be pros at synthetic division, synthetic substitution by now, right? All right, so given this, and we reduced this polynomial by a factor of x minus 1, what is the remaining polynomial? X squared plus 3. Absolutely. I would agree with that. So we write those. So we're not done yet because we need to find how many roots should we find looking at this original function? How many solutions should we find? 4. Now what we have here is we only have 2. We have -1 and we have +1. How do I find my last 2? Any ideas? We would factor it. Can we factor x squared plus 3? Yeah, not really, right? Not really. So what's another way that we can solve? How can we solve for the other roots? Set them equal to 0. Yes. No, we could technically use the quadratic formula. I try to avoid using the quadratic formula whenever possible. I don't like doing it. So yeah, we set the factor equal to 0. So let's go ahead and write that out. So we're going to have x squared plus 3 equals 0, right? All right, so how do we solve this? What do we do? What do we do first? Subtract 3 both sides. Very good. All right, now what do we do? We square root both sides. Yes. Right, so a little reminder, whenever you are solving an equation, And you are the one that square roots both sides. Never ever forget plus or minus. Again, I'll repeat that. Whenever you are solving an equation and you are the one that square roots both sides, like we did here, never forget plus or minus. All right. Sound familiar, right? Then what happens to that negative? The square root of a negative, what happens? It becomes an I, yeah. And the way that I show that is I like to circle my I, and I like to just kind of do a little arrow out in front. And to me, that kind of gives me a visual cue that that becomes an I. That becomes an I. And then can we do the square root of 3? No, yeah. So it's just going to stay in the radical 3 form, right? Square root of 3. All right, so we now know the other two roots. So in factored form, right? In factored form, let's write that out just for fun. We're still going to have the x plus 1. We're going to have the x minus 1. The x squared plus 3, we now know the two roots are plus or minus I rad 3. So we're going to have x plus I radical 3. And then we're going to have x minus I rad 3. Ooh, look at that, right? Look at that. Ooh, we found all four factors. Now, this problem, it wants us to write the roots in zeros. I spelled zeros wrong. No one noticed that. I put an ES. Zeros. Did I do that in every page? Yeah, I don't know. That's really funny. I just noticed that. Okay. Well, I'll fix that later. Anyway, so the zeros, our roots, we would say, well, x, or our roots equal x equals, we can say plus or minus 1, or we can actually write 1 minus 1, I rad 3 minus I rad 3. But I'm just going to be lazy and just put plus or minus 1 and plus or minus I rad 3. So those are the four zeros. We answered the question. What are the roots? Those are the roots. How cool is that? How cool is that, everyone? I think it's pretty cool. All right, so let me show you something else that might kind of open your eyes a little bit. So let me just cover up that graph. I need some space, so I'm just going to put like a white box on my screen to show you something. All right, so now this may be something that you've seen before, I hope, in Algebra 2 at least. X to the fourth plus 2x squared minus 3. Now, like we graphed it, we did synthetic division to reduce it, and it worked out great. But there's another way we can approach it, and sometimes it's a better way. One of my examples we're going to have here in a little bit, you're going to want to do it this way, I think. So looking at x to the fourth minus 2x, sorry, plus 2x squared minus 3 equals 0. We can factor this. So if you just look at this as x squared plus 2x minus 3, it's going to factor the same way. So let's kind of look at that, right? So let's go ahead and write that. So this is going to factor x plus or minus some number, and then x plus or minus some number. But instead of being x, it ends up being just x squared. All right, but it's the same idea, right? We want these two numbers need to add to 2 and multiply to -3. All right, think about it and go ahead and write it in chat. Which combination gives us that? So Enzo says -1 and 3. Anybody else agree? So we want two numbers that add to 2 and multiply to -3. So it looks like more people are agreeing, putting the same thing. Yeah, 3 and -1 or -1 and 3, it's the same thing. So we're going to write, so -1, oops, it's not my pen, -1 and +3, right? So -1 plus 3 is +2. And -1 times 3 is -3. So we factored this, right? We factored this to get down to here. Now, if you look at that, x squared minus 1, can we factor that again? Yeah, that's a difference of two squares, correct? So x squared minus 1 factors to x plus 1 and x minus 1. And then the x squared plus 3 carries down, right? Now, look at this. Look, this right here is the same thing we put over here. Look at that. Ooh, different approach. How cool is that? So sometimes, given a problem that maybe you do kind of do synthetic division and we get down, to this, but, maybe we get a problem right at the bat that kind of looks like this and we can't really, graphing this. Well, this one actually gives us 1 and -1, but maybe it doesn't. It doesn't give us nice numbers. Maybe factoring this is the way to go. So, keep that in mind when you're solving for your roots, that there's other ways to approach these problems and finish them. And, factoring like we did here is one way, right? And we basically, we completely, skipped over doing any type of synthetic division substitution to get to this step here, right? So I know, super cool, right? Everyone's super amazed right now. All right, so let's go on some harder problems, right? All right, so I have these 4 problems. I'm going to skip over them. This is just more practice of using Descartes' rule of sign. Feel free to come back and watch the recording later to work these out on your own. But here's these 4 you can work out. Here's the partial work of me just plugging in -x for the first one. There's the number 2, there's number 3, and then there's, actually, I'll pause a little bit more on number 2. Number 2, number 3, number 4, and then the answers. So you can work these out on your own. There's the answer key to check, right? All right, this right here, we want to use the rational root theorem. So you want to generate your PQ list, and then this one does say find all the rational zeros, like we did on that last example. Again, I'm going to skip over these because I want to get to some more, some harder problems. So here's these 4, 5 through 8. There's the solutions for them. So number 5, there's the PQ list, and then there's the actual roots for those, and so forth. These answers don't include the complex solutions, so you'll have to find those separately. Sorry. I didn't realize I didn't have those answers in there. But yeah, so you should have, like for this x to the 3rd, you should have 3 solutions. Yeah, we do have 3 solutions here. We should have 3 here. We only have 1, and then 3. We should have 3. So the other 2 are just complex solutions that I don't have listed. Sorry. All right. These are the 4 that I want to get to for the last half hour of this class. Ooh, I'm actually behind. 10 minutes behind schedule. Let's get through 2 of these. So I'm going to skip 2. Let me kind of look at my examples and see which ones that look like we should do. All right, we're going to skip number 9 because that's kind of like one we already did, right? It looks similar, so let's skip number 9 for right now. At the very end, I'll come back and show the work for it if you're curious. You can work it out on your own. Let's do number 10. Let's do number 10, and then we'll do number 12. Yep, number 10. So I'm going to give all of you, I think, 3 minutes, I hope is enough. All right. So time is up. Here's a question. How many solutions did you all find? 3. And how many solutions should we find? 3 again, right? And we know that because of the x cubed. So if you found 3 solutions, you did a good job. All right, what are those 3 solutions? -3 is one of them. Okay. And then plus or minus I radical 5. Anyone else want to agree with that? Any of you get plus or minus I radical 5? You got somebody else agree? Yeah. B agrees. Isaiah, Enzo. Good job. Anybody else? Right. So what did everyone do first? Magdalene, yep. What did we all do first? We graphed it. I think that's an excellent way. We could have generated a PQ list, right? But graphing it is probably faster than the PQ list. Unless, because the PQ list will generate fractions, which is nice, right? But yeah, graphing it. You guys make sure that you don't have your pen tool selected. For some reason, Isaiah, your pen tool is selected, and you keep doing dots in every page. And, I'm not going to lie, it's driving me insane. It says your name's attached to it. I can click the writing, and it shows who did the dot. So I don't know. Caught red-handed, right? Just make sure that your pen tool isn't selected, please. So B says he factored immediately. I'm not sure if that was a smart though. I saw factoring by grouping right away and solved. I think, you know what? That's excellent. So if you look at this and you solve by grouping, so it looks like we group the first two together. You group the second two together. You can GCF a 5 out of this group. You can GCF an x squared out of the first one. And then after you get there, you factor again. So I'm not going to go over the factor by grouping today. I don't know if I have a lesson on it, but you maybe want to write down the concept factor by grouping, and just check out online resources of maybe review on factor by grouping, because it is a really good way to factor. So nice job, B. All right. So by graphing it, what's one of the solutions we can see? Well, really the only solution we can see. -3. So let's verify, right? Don't be catfished by the graph, right? So what you see may not be what you get, but we have to verify. So not to bore you with the details, but we quickly do synthetic division. We get remainder 0, right? And then we get down to this. There's the factored form. And then what did everyone do from this step? If this is how we did it. We solved the x squared plus 5. So you set it equal to 0 and you solved. Yeah. Oops. So we set it equal to 0, subtract 5, square root both sides. The negative comes out as an I. The rad 5 just doesn't reduce any further. So there's the other two zeros that you all found. And then I went ahead, this is in the factored form, right? Going from this solution to factored form. And we have 3 factors, but make sure that when you finish a problem, you go back and read the question to make sure you answered it. So like on a TGA, on a test, if you stopped right here and you wrote this, I would mark it completely wrong because the question says find all roots. It didn't say find all factors. Find all roots. So this is factored form. You need to go one step further and write it in, the solutions, the x equals, the roots, right? The solutions, the x-intercepts, the zeros. So that's what we do, and all of you wrote down the answers already, but there they are. All right, how are we feeling about doing this stuff so far? Given a problem and you get to find the roots, how are we feeling? Pretty good. And hopefully we're all learning there's more than one way to approach these. Like B did factor by grouping. Excellent way. And when you factor by grouping, usually that only happens when you have 4 terms. So like we have 1, 2, 3, 4. So when you see 4 terms, there might be a good chance that this might factor by grouping. So that's kind of a giveaway when you see 4 terms, just so you know. All right. So it looks like 6 of you out of the 15 are still with me. The rest of you are tabbed out or walked away. I don't know. All right, let's get to number 12. This is the hard one. If you can do this one, I think you can do any of them. We got 9 minutes, so let's do this. Let's do 3 minutes. 3 minutes is probably not enough, but maybe you're really fast. So we'll do 3 minutes. 3 minutes, ready to go. I'll be really impressed if you can solve this in 3 minutes. I know, B. I'm not talking about you. All right, so it's been 3 minutes, and I'm pretty sure that nobody finished this problem. It's not enough time, but let's go through part of it, and maybe I'll give you some more time to finish the rest. So, Magdalene says that we need lots of placeholders when doing this, right? All right, so when you graph this, right, everyone probably should have graphed this first. I don't know if you could factor by grouping. Oh, we actually, it looks like we could have. Yeah, this one we could have factored by grouping too, it looks like. But anyway, if we graphed it, what does it look like solutions are for this? 1 and -1? Okay. Yeah. Yeah, there's 4 visible roots. So there's 4 there's 4 real roots, and we can see that, right? 4 out of the 6. So there's the graph. Now this one, so it looks like -1 and 1 look good as exact roots. This looks like a decimal to me, and we never want to write answers as decimals. In pre-calc, that's a no-no, unless otherwise stated. So if you give me answers as decimals, I'm marking it wrong. Sorry. That's what I do in this class. So no decimals in this class, sorry. All right, so everyone did synthetic division, and does -1 and 1 work? They do, okay. So let me just quickly show that. All right, so I think I did -1 first, and don't forget all your placeholders, right? You got to have placeholders. Now, if you checked graphically and -1 and 1 worked, but when you did synthetic division, if the story said it doesn't work, maybe you forgot placeholders. So we expect it to work, and it does, right? So one way that we can do synthetic division is, remember, we can keep daisy chaining them. We can keep stacking them, right? Rather than just writing them over again. So that's what I did. I just did it again, but this time with 1. Okay. So I just did it again with 1 to save, I personally like stacking them like this. And kind of it really flows and it goes a little faster, less to write. So we get this. All right. So we know the first two factors are x plus 1 and x minus 1, right? Based on this, what should I write after those two factors? Go ahead and write it in chat for me, please. So one person says x to the 4th minus x squared minus 2. Isaiah agrees with him. Anybody else? Magdalene also agrees. Okay. Anybody else still here? B agrees. Okay. Yeah. So that's what we have so far. All right. Give me a happy face if you got this far at least. You got this far in the problem. This is going to tell me who's actually here. Yeah, give me a. Okay. So I think 3 minutes should have been just enough time to graph it and to do the synthetic division, maybe to get down to here, maybe cutting it close. All right. Now from here, ideas of what we can do to, well, finish the problem. Any ideas? How much time do we have? Oh, 2 minutes. What do we do next? We have to factor the last one, right? So if we graph, so one way we can kind of approach this, we could try to graph this polynomial again, like x to the 4th minus x squared minus 2, and see if it crosses the x-axis at any nice places. But you will discover that graphing this will cross here and here, and those are decimal values, which means they are irrational. They're real irrational solutions. So it's a square root of some number that gives us that -1 point whatever it shows on Desmos. So we really have to factor it, right? We have to factor it. So let's do about, we'll do 30 seconds to factor this. And again, guys, I'm going to go over time by a little bit. So if you have to go to your next class, please, jump out of here and go to your next class, and then just watch the recording, the end of the recording later. Okay. All right. What did everyone factor that to? So write it out. What would everyone get to the factored form? So remember, I went over a problem like this when you have like x to the 4th plus x squared plus a constant. So Rachel remembers. So she got x squared minus 2 and x squared plus 1. right? So remember that factor is like, I call it simple method in factoring, right? We want two numbers that add to the middle and multiply to the end, right? So yeah, -2 and 1. -2 plus 1 is -1. -2 times 1 is -2. And just because it has x to the fourth and x squared, don't let that make it look harder than it really is. It's the same thing factoring wise if it was just x squared and an x right here. It factors the same way. The only difference is your leading terms, your leading x terms, have x to the second power instead of just being x to the first. That's the only difference, right? Yeah, you do a few of them, you'll get it. You just forgot. Don't let that scare you. X to the fourth, x squared number. You see that? It should be easy, right? So if it was x to the eighth and x to the fourth, would it still work the same? Yeah, it would. But then your leading term will be an x to the fourth power. Yeah, yeah. We won't do anything like that. That's kind of getting a little crazy. But yeah, Magdalene, your question. Yep, you could do it, but we won't do that in class, so don't worry about it. So it's whatever power the second is. Um, Yeah, the second power will just be half of the first one. Just like if this was x squared and this was x to the first, right? X to the first, one is half of two, if that's what it was. Two is half of four. If that was an eight and that was a four, four is half of eight. So yeah, any combination where you see that, it'll work. Sound good, B? Yeah, so if it was x to the sixth plus x to the fifth plus one, yeah, there's nothing we can do about it. We're stuck. Yeah, that right there would be a nightmare. And honestly, I couldn't even tell you how to factor that. We won't do that. All right. And from this step, what did everyone gonna do? Set them both equal to zero. Yeah. We can't, we can't really factor these directly unless you've done a lot of them and you understand how this is going to factor and how this is going to factor. I think it's really easier just to set them equal to zero and then solve them. And then once you have the solutions, put the solutions back in factored form. I think that is probably the easier way to do it. And that will allow you not to have to memorize how these factor exactly, if that makes sense. So both ways will work though. So we set them both equal to zero and we solve them separately, right? If you can all quickly do that, I'll give you 30 seconds to quickly do both of those. All right, what did everyone get for x squared minus 2 when you solved? Square root 2? Plus or minus? Yep, I agree. And the second one, what did you get? Um, Plus or minus I. Yeah, so make sure you show your work, right? So subtract 1 both sides. Then you square root both sides. Whenever you square root, don't forget plus or minus, of course, and the square root of -1 is I. Right? Is I. And then just for fun, there's the factored form of all 6 factors. Look at that. We got x plus 1, x minus 1, x minus rad 2, x plus rad 2, x minus I, x plus I. But the question says, find all roots. If you stop right here, I will mark it wrong because the question says, find all roots, not find all factors. This was just like a bonus step to write it like this. So you just got to write it all the roots. And there they be, all 6 of them in all their glory. Not so, not too bad of a question. Lots of steps, right? Pre-calc involves usually lots of steps. Nothing is really like a one step and done. This is not algebra 1 or algebra 2. This is pre-calc. Stuff is kind of complicated and intertwined and does take some thinking and working these out. If we didn't do that, this wouldn't be a very challenging class and it would be boring and I wouldn't want to teach it. All right, so let me go back to, before I stop the recording, let me kind of go back to numbers 9 and 11 just to quickly show the work, right? And 9, 11, 12 is easy. You can do 12, you can do 9 and 11. All right. All right, so, we graph it. We can see 2 of these zeros. So we just do synthetic division. First one with -1, we do that and we confirm that it works, and it does. Then we go on to the next one, we do with +1. We show that work, and we find that that also works. We then write all the factors, the x plus 1, x minus 1, and the x squared plus 4. We then set the factors equal to 0. We solve that, and we get plus or minus 2i, right? The negative comes out in front as an I, and its square root of 4 is 2. So we got plus or minus 2i. That is the factored form. And then the solution is, well, all of the roots written out, right? X equals 1, -1, 2i, and -2i. So that's number 9. Really straightforward. Number 11. Same thing. We graph this. We can, looks like we got, so we should expect 3 answers, right? X cubed, 3 answers. And look, it crosses 3 times. That means all of the answers will be real, right? Nothing imaginary, which is kind of nice. So looking at that graph, it looks like it's like -3 is an answer. So we do that. We do the synthetic. We confirm we confirm that it works. All right. So we're down to x plus 3 times x squared minus 3. We're going to go ahead and set the x squared minus 3 equal to 0. We solve that. Show all our steps, right? And we get plus or minus rad 3. Factored form, there we go. But remember, the question says find all roots. So we just have to say, all the roots equal this, or x equals all these solutions. And we get down to there. All right, so how's everyone feeling about solving for all the roots now? After going through all these, hopefully pretty good, right? If you're paying attention and working these out with us, should be feeling pretty good. Some a lot longer than others. So other than that, well, guys, thanks for coming. And as always, I hope you learned something. I will see you all tomorrow. Don't forget the quiz for 1.05 is due today.